Okay, this is section 3.1 of your Math Links textbook on squares and square roots. Your fundamentals or your foundations for understanding how to explore and how to use Pythagoras theorem. So we talked first in chapter 3.1 on squares and square roots. And the first question says, explain how to square the number. How to square the number 7. So we said that squaring a number, to square a number, is to multiply it by itself. So if I have 7 and I want to square it, 7 squared can be written exponentially as 7 with an exponent of 2, which can then be written as 7 multiplied by itself, which can be expressed as 49. Question 2 says, how would you use prime factorization to determine the square root of 225? So if I was to prime factorize 225, what you really do is you break any number down into the product of a string of prime numbers. And every number can be created by multiplying prime numbers by themselves. And of course, we learned that prime numbers, by definition, are numbers that have only 1 and itself as factors. So 1 is not a factor, a prime number, because it only has 1 factor. So 2 would be your first prime number. So what we want to do is figure out ways to multiply to get 225. And because 225 ends in 5, going back to grade 7 when you learned divisibility rules, you know that that means that 5 is divisible into 225. So 5 times what is 225? I can reverse it and use division. 225 divided by 5 tells me it's 45, which means that 5 times 45 is 225. I'm going to circle this number because that branch of my factorization tree is now stopped, because that's a prime number. But 45 can continue. 45, because it ends in 5, can also have 5 taken out. And 5 times 9. And finally, these two numbers, 9, can be broken down into 3 times 3. And when we analyze that, we have 4 prime factors. We have 2 5s and 2 3s. So 5 times 5 times 3 times 3 will give us 225. But because of the associative property of mathematics, we can rearrange those. And we can arrange them into 2 equal groups of 5 times 3 times 5 times 3 is also 225. But when I re-examine those prime factors, I realize that because they're equal groups, I can also state that 15 times 15 is equal to 25. And therefore, I can determine that the square root of 225, meaning what number multiplied by itself is 225, is 15. Because I've determined that 15 times 15 is 225. Question 3 gives you the factors of 36 as being 1, 2, 3, 4, 6, 9, 12, 18, and 36, or 1 times 36, 2 times 18, 3 times 12, 4 times 9, and finally 6 times 6. And if I rewrite them as that, I can see right here, oh, that's not what I wanted to do. I can see, take my highlighter, oh, that's not what I want to do either. Because 6 and 6 are factors of 36, which means 6 multiplied by itself, I can say that 36 is a perfect square. Or, alternatively, we said that if you have an odd number of factors, that must mean that one of them was repeated, and therefore that number, because it has an odd number of factors, must be a perfect square. Question 4. Explain how squaring a number is the reverse of finding a square root, and include an example. So if I take 4 squared as an example, 4 squared equals 16. And if I take that 16 and say, what number did I multiply by itself to get 16? The answer is 4. And we can do this with absolutely every number. If I take a number and square it, then if I square root that answer that it is, I will always end up with the original number I started with. So if I go 25 squared, that is 625. And if I say, what is the square root of 625? That would be 25. And question 5 says determine the prime factorization of 4, which is bizarrely easy because it's 2 and 2. And is 4 a perfect square? Yes, because 2 times 2 is 4. And if I drew a square, the area of the square could be 4, and the side lengths could be 2 and 2. Question 6 says a rectangle has an area of 64. Determine the prime factorization of 64. So I'm going to do that first. So I'm going to go, you could go 8 and 8, but I'm going to go 2 and 32. Did anyone here go 2 and 32? Or did everyone go 8 and 8? Everybody went 8 and 8? You went 2 and 32? 2 and 32? Okay. So I'm going to go 2 and 32 only because it adds for a little bit more suspense when we figure out if it's a perfect square. If you went 8 and 8, you know it's a perfect square right away because you've identified that 8 multiplied by itself is 64. But we'll break this down further, and we'll break it down even further, and we'll break it down even further. So what we've identified is that 64 has 6 prime factors, all of which are 2, which means that 2 times 2 times 2 times 2 times 2 times 2 equals 64, or that 8 times 8 equals 64. And it says draw a square. So 8 and 8, and the area equals 64. Question 7 says write the prime factors for each number and identify if it's a perfect square. So 42, because it's an even number, I know that 2 can come out because 42 ends in a 2. And that's 2 times 21. Now some people who aren't overly strong at math think that we're done now. 21 must be prime, but it's not. Because when you were in grade 4, you learned that 3 times 7 is 21. And therefore, it only has 3 prime factors, and automatically we know that if it has 3 prime factors, not factors, because that's a different question altogether, but an odd number of prime factors means it's not a perfect square, which is weird because it's the opposite of what I said before with regular factors. If it's an odd number of regular factors, it is a perfect square. But if it's an odd number of prime factors, it's definitely not a perfect square, which is immensely confusing. 169 is the hardest one, I think, in the world to factor because people are like, I don't know what divides into 169. And the reason why it's hard is because it is a perfect square. 13 and 13 are both prime numbers, and therefore it is a perfect square because 13 times 13 is 169. It's very hard. And 256 is cumbersome, very cumbersome. It's 2 and 128. It's 2 and 64. Now remember in the last question when we did 64, I went 2 and 32? Well, now I'm cheating. I'm going 8 and 8. I'm not going that far. So when I'm done of it, when I prime factorize 256, I have, and I'll use my highlighter here, 1, 2, 3, 4, 5, 6, 7, 8 2's that multiply together. Or 2 times 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 2. There's my 8 2's. Or 16 times 16, which means that yes, it's a perfect square, and it also means that the square root of 256 is 16. Question 9. This is what is the area of a square with each side length? So it gives you the side length. I'm going to draw a square. I'm going to put those little lines on to say that every side is equal. And I'm going to put a 10. And the area, the formula for area, in grade 7, you learned that it's side times side. In grade 8, we're going to learn, instead of saying side times side, we now know that that means side squared, which means side times side. So we're going to write our formula first. Then we're going to substitute our S for 10. And we're going to simplify it. So the expectation is on your test. You can draw it, you can write the formula, you can substitute, and you can simplify. and you'd put 100 in here. For 16, you'd put 16 here. You go area equals side squared, or area equals 16 squared, which if you go back in time, I think it was the one we just did last question, which means it's 256 area, and area equals 256. Your next question, oh, we're going to skip this one. We'll go on to 11. What is the square of every number, of each of these numbers? So 9 squared, what is the square of 9 squared? Well, 9 squared means taking it and squaring it, or putting an exponent of 2, which means 9 multiplied by 9, so it's squared is 81. I'm skipping the odd or the even ones. Yeah. The second one, 11 squared. What's the squared? Is 11 squared, which is 11 times 11, which is 121. Question 13, what is the side length of the square shown? Now, there are two ways to do it. The first way is by inspection. You say, well, what number did I multiply by itself? You're saying this in your head. You get 49, and you would say it must have been 7. So therefore, 7 times 7 is 49. That's the first way you can do it. It's called by inspection. But the second way is using what we learned in grade 7 and 8 with algebra, called opposite operation. Now, pay attention. The formula for the area of a square is side squared. So I'm going to start with my formula. Now, in the story problem given here, what do we know? Do we know our side length, or do we know our area? We know our area. So I'm going to substitute 49 here. Okay? Now, opposite operation. Remember when we did algebra, if I multiplied this side by 2 and multiplied this side by 2, it kept it equal. If I subtracted 8 from this side and subtracted 8 from this side, it kept it equal, etc., etc. So, this is the fundamental purpose of algebra. If I take this scale of equality, which this equal sign represents, if I square root the entire side and square root the entire side, as long as I do something mathematical to one side and do the same thing to the other, I'll keep equality. So watch what I'm going to do. I'm going to square root this side. I'm going to square root that side. What number times itself was 49? What's the square root of 49? 7. Now here's the hardest part. What's the square root of s squared? S. What number multiplied by itself was s squared? The answer is s, because s times s was s squared. And when I do that, I've solved this story problem with opposite operation, and I now know that the side length must have been 7. Your next question, question 14, says determine the area of the side length, of a square with an area of 900. So really, question 14 and question 13 are a lot alike. The difference between the two, so these two questions are the same. The only difference is this has a picture and this one doesn't. So they're really the same question. So if I drew the picture, I put area equals 900 centimeters squared, that's what the picture would have looked like. So you could ask yourself through inspection, what number times itself? So you can solve it by inspection, meaning what number did I multiply by itself to get 900? Now the problem is, that's a little hard, right? So by inspection, it's not easy, but if I take area equals side squared, so area equals side squared, and substitute what I know, area equals side squared, then just like the last question, if I square root both sides, I can use my calculator to say what is the square root of 900. So I put 900 in. Now on my calculator, mine's a little different than yours probably. Right here, that's the square root button. I have a 2, which means square root. I have a square root symbol, and then I have x. So if I press that, it tells me the square root of 900 is 30. So I have 30 here equals the square root of s squared, which is s, which means the side length is 30. Question 15, simply evaluate what is the square root of 49, or if you're asking yourself the question, what number times itself is 49, the answer is 7. What number times itself is 64, the answer is 8. And what number times itself is 625, you might not know. So you could guess, because it ends in 5, you probably know the number itself ends in 5. But you can take your calculator, use your square root button, and it will tell you 25. So 25 times 25 is 625. Skip 16, go on to 17. A fridge magnet has an area of 54 millimeters squared. Is 54 a perfect square? So use prime factorization to determine whether it's not. So the area of this fridge magnet is 54 millimeters squared. If it's a perfect square, there will be a number that multiplies by itself to give you 54. 2 and 27 gives you 54. 27 is 3 multiplied by 9, and 9 is 3 times 3. So what I realized is I have a string of 4 prime factors, 2, 3, 3, 3, and there is no way I can multiply those together to get anything close to 2 identical numbers. So therefore, it is not a perfect square. Floor mat for gymnastics is a square with a side length of 14. So the first thing I'm going to So once you have it drawn, you put your 14 on. So it's a 14 meter by 14 meter mat. And what is the area of the floor mat in meters? So obviously, if I just drew the picture, I can do the 14 times 14, which is 196. And I get the area is 196. But that's too easy. Let's use our formula again. So area equals side squared. So the area will equal the side, which is 14. And if we square it, we could then say that its area is equal to 14 times 14. But we'll use our calculator this time. So 14 squared, I also have a square button, which is the x squared button. And it tells me that the square of 14 is 196. So the area of the whole mat would be 196 square meters. Question 19 said, a gym teacher told the students to run twice around the perimeter of the school field. The area of the school field, which was square, was 28,900 meters. How far did the students run? So here's the field, and the area is 28,900 square meters. So if I'm going to determine how far they ran around, I better figure out first how long a side length is. So since area equals side squared, then 28,900 will equal whatever that side was squared. In order to solve this, once I substitute it, I'm going to square root both sides to isolate the variable, because side squared square rooted is s. And the square root of 28,900, I obviously don't have any idea unless I use a calculator. So put that in, use your square root button, and it tells you it's 170. So therefore, 170 multiplied by 170 gave you the 28,900. So that's the side length. But now we have to figure out, if he ran around the field 2 times, how many 170s did he really travel? Well, he really traveled 8 multiplied by the 170 side length, right? Use your calculator, because I don't know this answer. So take the 170 and multiply it by 8, and you get, therefore, he ran, or she ran, or they ran. He ran. I forgot the number. 8 times 170 again. 1360 meters. Or if you want to make a nice conversion, 1.36 kilometers, because 1,000 meters equals 1 kilometer. Question 20 says, Adam's uncle had instructions for building a shed. One page of the instructions below is not very clear. What is the area of the rectangle? So area of rectangle, of course, is the formula area equals length times width, which would mean the area of this one would be 9 times 4. So the area equals 36 meters squared. But right here, highlighted in yellow, says the area of the rectangle does equal the area of the square. And since the rectangle is 36 meters squared, then that must mean the square has an area of 36 meters squared. And if its area is 36, then we know its side length must be 6 meters. Question 10 says Kate is going to put a patio in her backyard, and the patio stones she is using have an area of 1 square meter each. She has created the rectangular design below. what is the area of the patio? So this is a rectangle. So area for this A question will be length times width, or 14 times 4, which is 40 plus 16, which is 56 square meters. If I was to count these, you would find there are 56 squares that she used, because each of them is 1 square meter. What are the dimensions of another rectangular patio she could build with the same area? So what we're really asking is, what are the ways we can build it? So we're looking for the factors, or ways we can multiply to get 56. One of those ways is 4 times 14 to get 56. But another way she could do it is she could build a big, long 1 meter by 56 meter patio. She could also build a 2 by 28 meter patio. That would work. And she could also build a, what else could she build? An 8 by 7 or a 7 by 8 patio to get that. Those are all of the different dimensions that she could use, and they're all the factors of 56. But ultimately, Kay decides to make a patio with the same area, but wants it to be square with whole numbers as side length. Is this possible? Explain your reasoning. The answer is no, it's not. And the reason is right here. That in order for it to be a square, there must be one number that multiplies by itself to get 56, and there is no number that multiplies by itself to get 56. She can get pretty close, and I'll show you what I mean. So if you took 56 and you square rooted it, you would get 7.5 roughly. So if she was able to cut bricks, she can kind of create one, but it's not exactly 56 square meters. It would always be approximate, but you could kind of make one. Just have to be decimal meters instead of whole numbers. And finally, question 22. The world's largest city is the world's largest city square, is Tiananmen Square in Beijing, China. It has an area of 396,900 meters square. So this is Tiananmen Square, and its area is 396,900 meters squared. What are the dimensions of the square? So again, area equals side squared. Area equals side squared. If I square root, okay, that's great. So if I square root both sides, the square root of s squared is s, and the square root of 396,900, using the square root button, is 630. So therefore, the side length of Tiananmen Square is 630 meters long. That's pretty big. It's over half a kilometer long. And it said if the square had dimensions of 629 by 629, what would its area be? So making it slightly smaller for whatever reason, but 629 instead of 630 and 629, if it was 1 meter less in dimension, then if I multiplied 629 and used the square button instead of multiplying it by itself, it would be 395, 641, 395, 641, which we can see is over 1,000 square meters less. And if the square had an area less than 394,000 meters squared and greater than 386,000 meters squared, what are all of the possible dimensions that it could have? So what we're going to do here is we're going to say, well, what if it was 394,000 meters squared? Okay, and I'm going to take my calculator and go 394,000, and I'm going to square root it. I'm going to get 627.7 roughly. Is roughly, so the square root of that is roughly 627.6. 627.6 meters if it was that. So it has to be less than that. So the first whole number that we're going to get when we get there is 627 meters. That's the first whole number that will be less than this. And if we take that 386,001 and square root it, and take our calculator again, and say 386,000 and square root it, we would get 621.3 roughly meters in length, which will be the greatest whole number will be 621 meters in length. So therefore, any number between 621, whole number between 621 and 627, meaning 621, 622, 623, 624, 625, and 626, and finally 627 meters, all of those squares will have areas that are less than 394,000 meters squared and more than 386,000. So just to put that in perspective, this would be a 621 by 621, and that would have an area more than this, but less than that. And this one right here, to make it the last one, would be 627 and 627, which would be less than this area, but more than this area.